That's Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada. We're just doing our little desk Ladyada check-in, what I'm up to. So we designed a bunch of hardware this week, did a lot of drivers. I'm basically trying to clear off, like, my desk. You can't see, but it's like covered in little pink bags with circuit boards in them, prototypes that I have to get drivers written or debug or do something. So if we go to the overhead, I'll show off some things that did get done. So
And the question is, we have two overheads. So this is one overhead.
Yeah.
Right? This is the previous old one.
Okay.
Oh, there you are. Hi.
Yeah. Hi.
Then here's new overhead. Bam.
New overhead.
Okay. And do you want, if you hit focus on it, I think new overhead looks a little bit better.
It looks a little bit better. Okay.
Yeah.
Yeah.
It's better. It's
okay.
sharper. Yeah.
It's a little sharper.
Yeah. It's good.
Okay. Cool. I just have to look.
Sharp.
So we got the BMP 581 in the shop last week, and then we're going to follow that up with the BMP 580, which is like the slightly less well calibrated one. Here. Let me put my little sticker. Oh, you know it.
What?
Autofocus, but you can't focus lock.
You can, huh? I bet there is if you install like an app or something.
Yeah.
Yeah, that's what.
No, there's only like one button on here. Oh wait, there's autofocus. Oh no, there's S and
I
there's.
bet you have to press and hold.
No. There's
You did it.
There's a switch.
Yeah.
Okay. So there's a switch on the side that says AFS, and I was like, I bet that means autofocus. Stop doing the thing that annoys Ladyada. And I was right.
Yeah. Sort of
Okay, great. So it's actually, I like that this is nice and compact. It is very crisp. Okay, so as I was saying, so the BMP 581 is in the shop. BMP 580 and BMP 585 are coming next. Those are the ported, that's the ported version and the slightly less expensive, like not as calibrated version. So that's getting done. Yay. And then we did the MLX 90632, that was the FIR temperature sensor. Actually, like I was kind of like waiting to see if there's any feedback. It's like I was having a little bit of weirdness with it, but it seems to be okay.
Yeah, not bad. Look at this. It zoomed in.
Yeah, that's nice. It's pixely. Okay, and then I also got the driver for this other. So there's this MLX driver.
You have to look right there.
Whoa. Hi. Close. And then there's this very similar look, because as I was looking for that, I also found this. So this is a the ST, God, ST just picks like the ST HS34PF80.
That's what we were going to name our kid.
I know. Well, no, because we were going to have two S's.
Oh.
Double S. So this is it's kind of like a PIR sensor. It's not a millimeter wave sensor. It's a PIR sensor-ish thing where it has, like, you can kind of see there's this infrared light catcher. So it's actually, ironically, it looks very similar to this, but it does do remote temperature, although it's not calibrated. So with this, it can detect when there's motion of a human, because it's looking for the infrared signature of like a large body of hot water, which is usually like a person or like a big dog, or like somebody's like walking into a bathroom and they want to turn on the lights automatically, or you want to detect when somebody's passed by, something like person counting. So I got the driver for this going. So ironically, okay, so go to the computer. So there is yeah, sorry. Yeah, it's okay. So I know there's a lot going on. There is, I wrote a driver for the STHS, and what I did is I worked, I like that now it says with Claude, because people are like, I don't know whether you're writing stuff with AI, and the answer is yes, I am, because you know what's interesting? This is like the first time in my life I have no neuropathy anymore. Like I used to have like very serious, like numb fingertips from typing, and I actually don't have that anymore.
But you didn't mind.
I suffered, but
you
it's
didn't
okay.
mind the minerals to make the computer.
Well, you don't know that. You don't know what I'm doing at 2 in the morning. You're asleep.
You're in the backyard mining minerals, but I don't know if it's for this though. I don't know. I don't see certificates.
Nobody knows. So you still have to write the code. I just get help doing it. I just don't have to do the typing.
Woman's work.
Yeah. So the driver I wrote uses Bus.io. So there is, if you go to like GitHub and like I think I think if you just go to GitHub and like STSH34, there is a driver from, but I don't remember what the hell it's called, PF80. It was from ST. I'm never going to find it now. It's like it's like ST API or something. I don't remember. Anyways, ST did write a driver for this. C API driver. Whoop. Yeah, there's like, there it is. ST micro. So they did do a driver for this, and it's like in pure C. And I used this to write my driver, but the reason I didn't, sometimes I just wrapper like a driver, especially if it's in C. Because what's nice about this driver is all you have to do is give it the function calls. You basically give it function calls for reading, writing, I2C, and delay, which is really nice because you can easily port it. The problem is I actually did want this to be get ported to Python/CircuitPython API, so we could use it with like a Raspberry Pi or with CircuitPython. Then people could use it with MicroPython if they so wished. And to do that, it's much easier for the folks who do the porting to do it from Bus.io. So I just kind of like, I just divide all the drivers, and then there's a couple of like, there's a few functions that were kind of wacky, like this write embedded function, which you need to reset the algorithm. And so that I did do porting. And what's interesting is when I gave the function to Claude Code and I said port it, it like skipped sections. But I found what does work is saying, write inline like put all the code from the function you're porting inline, and then underneath it write like our implementations. For example, this is how that API driver does the reading the register, saving the ODR, the output data rate, and then putting it into power down mode. And we have a function called get output data rate. So it's a kind of like, does that work for you? And then we can set the data rate like manually through our function. So it's like, as long as I told it inline each function, it was able to do it properly. But if I just gave it the function, it actually kind of like did not do a great job. So as always, use AI for like tool, like if you're using it as a coding assistant. This is the first time I've actually given it a function and told it port this function over. So I've again learned some of the techniques for that. So gonna get some of these chips. They're in stock at DigiKey, which is really great. So I'll pick some up, and they're not like too expensive. Like they're not as cheap as because it counts as an IR sensor, which can make sense. They're not like as cheap as a PR sensor, but not too expensive, like $3.50 in quantity. So we'll get some of those. Once we get those, we'll get the breakout boards assembled and get that in the shop, because I did get this working. Okay, so next up, last week on INNPI, we did the AP 337732C. Is that 32S? 32S? 2S. That's the other name we were going to pick with our kid. So this is a cool chip. Yeah, it was a featured product. So we featured it on INPI. So check it out, and I go into more detail with it. What's neat about this chip is it has extended power range. So it can do up to 28 volts. Whereas our standard, if we go to our USB PD, like we have cables and we have a breakout. I don't know where our breakout is. It's over HUSB. This dummy breakout only does up to 20 volts. I mean, it's inexpensive. It's like $6. So, this is nice. You can just cut the trace and you select which one you want. So this one only does up to 20, but people want maybe 28. So this can do 28. I think it can also do up to 5 amps, which is nice. Although, to be honest, I have to check to make sure that's true. It's also a little bit less expensive than the HUSB chip. So this one, the only thing that's a little, annoying is that there's a standalone version, the C, and the non-standalone version, the S. And so I started with the S. Oh, another thing that this does that's nice that the HUSB doesn't do is it does PPS, Programmable Power Supply, which I also covered in the INPI. That's an ability for you to actually select the exact voltage and current limit by like 220 or 50 milliamps and 50 millivolts. Maybe it's the other way, 20 millivolts and 50 milliamps. And what's interesting about that is basically you can turn it into a constant current / constant voltage power supply if it's supported by the USB power adapter, which again, not all do, but like Anker has a series that does, and there's a couple other companies that make ones that do. Not like their Apple one isn't going to do it, and some of the cheap ones don't, but you can get one that does. And what's neat is I remember like a long time ago, I got like a bike light for my bicycle, and it came with a DC power plug, but the DC power plug was like 7.4 volts, 500 milliamps constant current. It was actually like just doing direct. It was like plugging directly into the battery to charge the battery. There was like no charge controller. And it was like, this is the most dangerous, insane thing I've ever seen. But it's that same idea. It's like if you had something very, very inexpensive where you don't even have a microcontroller inside of it, you're like, look, there's a big battery. It's like a lamp. Use a big battery. And then you just want to have that battery, drive lights or a sound amplifier, whatever. You don't even have a charge controller. You just tell the USB power delivery, put yourself in 4.2 volt fixed voltage output, 1 amp current, and now it's a LiPo charger. Is it a good LiPo charger? I don't know, but it's okay. So I designed a breakout board for that. But I don't remember where I put it. Not here. Maybe it's under USB. Yeah, but under USB. So I designed a breakout board for the I2C version. I'll do one for the standalone version next. I didn't get to it this week yet, but I'll do it when I'm done. But I thought this was a cute little design with, hold on, boop. USB-C input. So again, you connect that to your power delivery board, whatever. There's the power good LED. There's the output status LED, terminal block output. There are some GPIO if you so wish. There's like interrupt, over temperature. OTP is not 1 time programmable, it's over temperature protection. STEMMA QT if you so wished. And a little 3 volt regulator. You get 3 volt out. I figured like there's a little bit of space. I was like, well, it's good to have 3 volts. Output linear, although I don't know, maybe I should have made that a buck converter. And then the APS, well, it's not APS, it's AP33772 over here. Okay, so that'll be cool. So I like that it does extended range, it's kind of nice. And the PPS might be kind of neat. Okay, and then how are we doing on time?
You're up to 13 minutes.
Great. We're going to combine the next thing with the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada is a part of engineering help you as you find the things you're looking for on digikey.com. It's time to update this graphic with the new overhead because there was no reason to really have this as the graphic now because we have new graphics. So
Okay.
First thing I'm going to do is disappear this one.
Okay,
just
bye.
Just say, oops.
See you later, alligator.
Say bye.
Bye.
Then we want to add the new one.
Do it.
That's if you need the overhead, right?
I will not use the overhead for the rest of this, but yeah, here's the
Yeah.
overhead. Okay, these are
All right,
some
it's
tips.
kind of
from
nice.
me. Okay, cool.
Okay, and then for here, this is when we're going to need to use the computer
Yeah.
because, in the sense of talking about the site, DigiKey without you need DigiKey.
Okay. Great. So we got a request this week, actually 2 weeks ago. Folks love the CAN bus FeatherWing. That's our way of adding CAN to any of our feathers over SPI, so you don't have to have native CAN support. We also have a CAN BFF. Ditto, this lets you add CAN to any board that has CAN support. And what's nice is that it uses the MCP 25625. So this and that FeatherWing, which uses the MCP 2515, are like kind of the most classic CAN adapters. Like if you don't have native CAN support in your chip, which a lot of chips don't, It's SPI to CAN, so it's like very easy. There's drivers in like every language. We have it in Arduino, we have it in Python. People have their drivers for Linux. There's drivers for like every chipset. Because again, it's inexpensive and common and easy to use. You don't only need like SPI and then reset and standby if you want. And then you have some protection here, and then we have an optional terminator. But the person said, hey, I like the MCP 2515, which is, data sheet is here. Boop. But this chip is a little older. First designed in 2003, and it only has CAN. It doesn't have CAN FD. And they're like, can you make a version that has CAN FD support? And I was like, I don't know what that is because I'm not like a big CAN person. But CAN FD is flexible data rate, which actually, if you use CAN, is kind of like obvious, because one of the things that's a little annoying about CAN is it is a multi-drop network, but everybody on the network has to have the same baud rate. So you kind of have to pick like 250 kilobit per second, whatever, 100, 25, 3. You have to pick some number, and everyone's got to talk on it. You can like listen in and sort of figure out what is the baud rate that's being used, but it'd be kind of neat if it's like flexible and you add new devices. They could automatically adapt to whatever baud rate's on there and then transmit in a way that's detectable by everybody else. And so this was done in like 2012, which makes sense that the MCP 2515 is like in early 2000s, was designed before CAN FD. So what we should do is let's find if there's a chip that's like the 2515 and the 26525, which is the CAN controller plus transceiver all in one, and find if we can update our designs. Hopefully don't have to even do much firmware update to get that working. So first up, let's look at the 2515 so we know where it is. Carmen San Diego. It is under interface controllers, and it's like a CAN bus controller. So, and it says CAN 2.0. It doesn't say CAN FD, so maybe that's what we have to look for. But let's go to controllers. And as always, we're going to pick active and, normally stocking. And, okay, great. So there's like USB controllers, and there's USB host, and this is a hub. So it's kind of like this category, sort of like a little bit of everything. Let's find CAN bus. Okay, look, there's CAN over here, and then there's interface over here. So, yeah, this is like USB to serial. There's a lot of options here. So the protocol, and then the function, and the interface. So it looks like, because there's like SPI to CAN here, and this is NCP series. So we want interface SPI, because that's basically the same as what we had for the 2515. So let's go to interface and let's type in SPI. And there's like a bunch of, we'll just select them all, because whatever. And then the protocol is CAN or CAN bus, because they're two names for the same thing, right, pretty much. Okay, cool. So now we have about 35 results. That's great. It's a much smaller number. So we've got that MCP 2515. What's interesting is that you can kind of tell Microchips sort of owns this category, which is cool. So 2501, 2518, 2515. The only thing that's a little annoying is they don't tell you which is which. There's also one by Holt. It's like $15. We want something inexpensive. So the question is, how do we know? Well, this is one of the situations where I'd actually say go back to the site where, like, if there's only one supplier, like sometimes it's just like, wow, like only ST or TI or Microchip or Analog Devices or Maxim makes like this particular thing, and they have a family of them. I would just say, like, go to their site. They have like a microsite or a page for that product, like they do here, and then you can search within it. So it looks like they call CAN 2 and CAN FD separate. This is an MCU, MPU, and we want transceiver, I think that's, or controllers. Yeah, we want the controller, right? Because that's, yeah, the MCP 2515 is here. And let's view all the parametrics. Let me see if we can get some more details. Hold on. And then, okay. So yeah, here there is a selector for does it support CAN FD? And the answer is the 2518 and the 2517 do. What is the difference between the two? Let's see. Let's compare these. Can we compare? Okay, so looks like they have different pricing, same voltages. Wish we could say like just show me differences. Looks like there's a little bit, it's a little bit slower on the 2518, only 17 megahertz, which is still quite fast, and a little bit more current. Otherwise, it looks pretty similar, and the pricing is kind of significant. Look, if you really need 20 megahertz, pick the 2517. Otherwise, let's go back, and then we can now select the MCP 2518 series from here. So let's search for MCP 2518. Let's see what comes up, because there's going to be a bunch of options. Okay, so yes, they have a ton. They even have, we didn't mean to, but this is the version that is with the transceiver built in. That's the separate like differential 5-volt manager that often is separated, but in this case, they just plunk it into one die. And it's not too much more expensive, to be honest. You can get the 2513 for like 160 and the non-integrated one for 148. Honestly, it's like the same price as if you did get that separate chip. So unless you need a separate chip, I think it's a transceiver. That's probably fine. What's cool is they have it both DFN, nice compact, and easy to solder SOIC. They do not have dip. Looks like there's a couple different, there's extended temperature maybe. Yeah, this one does up to 150 degrees C. This one does 125. Different temperature ratings. They've got the all-in-one. So the all-in-one is what I would use. Let's just look for in stock right now. The all-in-one is what I would use for the BFF, the QFN, which is kind of nice and compact. But for the FeatherWing, I would use the SOIC. Why not? It's easy to solder. Or maybe the DFN, also nice and compact. So let's look at development, dev, 1 second. Dev boards, FeatherWing, nope. FeatherWings, CAN. And I did a design earlier this month, and you can see, yeah, I just swapped in the 2518 here instead of that bigger SOIC. Almost no other component needed changing. There's like one less pin, there's no reset. So I disconnected the reset pin, but other than that, everything else pretty much stayed the same. I added a switch for the terminator, but this was very easy to do. So, I'm going to get those prototypes back. But, I think if you're going to add CAN to a product now, since it seems like most people want CAN FD and the pricing is almost the same between the 2515, 2518, just upgrade to the 2518. The driver is a little bit different, but there's example code for both. And that way you get backwards compatibility, but also works with those flexible data rate networks that some people have for their CAN buses. So that's my pick for the Great Search.
That's Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
All right, that's the show for the week. We'll see everybody all throughout the week and more. Stay tuned for surprises, fun, and a little bit of
All right,
good
summer vacation's
trouble.
almost over, and break time's almost over, folks. Break time's getting over, folks, so.
Vroom, vroom. Okay, we're going to go.
Back. All right, bye, everybody.